check these last problems from the checkpoint, the last checkpoint of this section 9.4, and we're going to pick up with number 7, which is y equals x squared plus 1. All right, so in this case, A is -1, B is 0, and C is, oh, I got this wrong, C is 1, although it doesn't really matter in this case. Okay, C is 1. All right, now the x of the vertex is going to be x equals minus b over 2a, so that's 0 over -2, which is equal to 0. And then we're going to plug that x into our quadratic, and we're going to end up with 0 plus 1, so that means y equals 1. So our vertex is x equals 0 and y equals 1. Our axis of symmetry is going to be x equals 0, 1, the vertical line, around which the parabola will be symmetrical. And in this case, x equals 0 is really the same thing as the y-axis. And because our leading coefficient's negative, it's -1, that means our parabola is going to open down. Now, I picked some points in here and calculated them out, but eventually you can just do them in your calculator, as I showed you how. And so you find these points, and then the next thing you're going to do is you're going to plot those points and sketch the graph. So this is what the graph y equals -x squared plus 1 equals. Now I just want to also make sure that you understand that this negative that's out here is not getting squared. The only thing that's getting squared is the x. So when I go over here and square, that negative is floating outside of what's getting squared, and it gets plunked onto the x after you're done squaring. So everything that comes out of there is going to end up being negative, right? Because every time you square a number, whether it's positive or negative, you're going to end up with a positive number. So that negative there is going to force everything that comes out pretty much to be negative, except I guess when you get 0. All right, so so this is our graph. So that's number 7. Okay, so moving along. Number 8 is y equals -x squared plus 3x. In this case, our A is -1, our B is 3, and C, we don't have a constant term, so it's equal to 0. The x of the vertex, when I do the math for that, that's going to be -b over 2a, so it's -3 over 2 times -1. That's going to be a positive 2, so it ends up being, a -2, so negative and negative make a positive, so it turns out to be 3 over 2. That means that I have to put that into the x here to do the math for that. And of course, I end up having to do some fraction math. When I do that, I get y equals -9/4, because that's what 3/2 squared is with a negative in front. And then I have to multiply 3 to 3/2, and I get 3/2. There, now I have to get a common denominator 4 here, so that becomes 18/4. So I get -9/4 plus 18/4, that's going to give me a positive 9/4. That's the same thing as 2 1/4. So our axis of symmetry is right here. X equals this. X equals 3/2, 1 1/2. Our parabola is going to open down, and I'm going to pick points around the axis of symmetry. And so there they are. Pick those points. And these are dashes or underlines. These are not negatives. So, and then I figure out the y values. And again, I could use my table and my calculator to do that. And then when I come over here to 8, I graph, there is, my 1 1/2 and my 2 1/4. There's my vertex right there, approximately there. I'm just sort of guesstimating. And then I plot the rest of these points in. And I keep track of the fact that I have symmetry, going on here. And so I know that these are all equidistant from the axis of symmetry. And then I sketch in the graph. All right. And if you need to look at that a little bit more, you can always hit pause and look at it just a little bit more. Number 9, y equals -2x squared plus 4x plus 1. So A is -2. And since it's negative, I know my parabola is going to be opening down. B equals 4, C equals 1, and when I calculate the x of my vertex, -b over 2a, it's -4 over 2 times -2, which is what a is. I end up with a -4 here, -4 divided by -4, that's going to give me a +1. And then I'm going to put that 1 into the x of the quadratic to figure out the y of my vertex, and that comes out to 3. So my vertex is at 1, 3. My axis of symmetry is at x equals 1, vertical line going through x equals 1. Like I said before, it's going to open down because of the negative leading coefficient. And then I'm going to go and pull some points to the left and right of my axis of symmetry and my vertex. So I pick these points to the left, and then I pick these points to the right, and you find the y values for those. And then you're going to plot them into a graph. It'll look kind of like this. And you're going to sketch this. And you remember to put arrows on your parabola. Here's my axis of symmetry. I have that in kind of faint. And you can see, again, I'm equidistant from the axis of symmetry on each of these sides. So, all right, so let's look at that last summary box there on page 522. It says graph of a quadratic function. The graph of y equals ax squared plus bx plus c is a parabola. If a is positive, a is the leading coefficient, the parabola opens up. If a is negative, the parabola opens down. The vertex has an x-coordinate of negative b over 2a, and what they don't have in here is that you're going to use that value of x to find y also, so you know the y value of your vertex. The axis of symmetry is x equal negative b over 2a, because of course once you calculate what x is, that's what your axis of symmetry is, the x of your vertex. And then the y-intercept, of course, is c. And why is that always true? C is always this number here, the constant, because if I remember the y-intercept is where x equals 0. So every time I have terms that have x in them and x is 0, these terms will go away. And so this always ends up being your y-intercept. C will always be your y-intercept. All right, so that is it for section 9.4.